Hey, ladies and gentlemen, welcome for joining me here for lesson 9.1. Sorry, I'm a little shaded, evil looking, or villain style. Just not a lot of lighting right now, but that's okay. Our goal today is to construct, interpret, and describe patterns in scatterplots. So we're going to focus pretty much on the interpreting and describing patterns in scatterplots. Scatterplots is just a fancy way of saying that we have a lot of information to figure out, and sometimes it's not as easy as linear. So with our information that we did in chapter 4, we went ahead and plotted some lines, tried to interpret some information looking at that, but it was all linear, exactly linear. But usually, like it says there, doesn't represent normal life. Because life is a little bit crazy. So, for example, we might have it going up, down, maybe driving, you get a flat, and all these different things happen where, yeah, you got to go ahead and spend money on tires. Maybe your gas mileage isn't getting as good. So, again, we're going to go ahead and use scatter plots. Now, this scatter plot here, maybe you haven't been to the beach for a while, but this kind of makes sense, right? As we learn to describe it, we always talk about the x-axis. Then we talk about the y-axis. So obviously, as it gets hotter, right, more people visit the beach. So as you notice, it's not exactly linear, but it's kind of linear. Kind of looks like it's going uphill, where the before, that graph is definitely going uphill. Scattered, so that information is just kind of put out there. Real life situations, that's the key here. So our scatter plot is the relationship between x and y. Now remember, x-axis we always start with first. Then we talk about the y-axis. So you can go ahead and again, notice that this is going to be in your textbook. You can sketch it. You can always pause the video and sketch it. But we've got 4 types. This one here, it looks like it's going uphill, right? So we're going to call it positive linear. This one here looks like it's going downhill. So we're going to call it negative linear because it's kind of linear. Ooh, what's that one called? We'll see. And that one, that one kind of looks like a U or a check mark. So the first 2 are very similar to what we've already seen before, but the other 2, not so much. So again, it's kind of linear, and it's going uphill. So positive linear correlation. Sometimes people call it a positive linear relationship. We got to make sure we understand both words there. Correlation, relationship, kind of go hand in hand. So the way we would read it, again, starting with the x-axis, as the temperature increases, because remember you start out at 0, maybe even start out at 70. As the temperature increases, the number of Slurpees sold increases. Or you can talk about ice cream, right? Or cold drinks. Essentially, when it gets hot, people buy more cold drinks. But what about the negative linear correlation? So it's going downhill, right? Like a negative slope. Excuse me. As the car age increases. So again, the x-axis first, the car is aging, so the car is getting older. The value for that car decreases. Definitely. But notice that guy right there. We call that an outlier. Now, sometimes you may have a really old car or see a really old car that's worth a lot of money. More of a collector or collectible item. And again, an outlier doesn't fit that data. The age of the car really makes it worth more for some cars. All right, this one here, I can't make it negative linear like the previous one. I can't make it positive linear like the first one because all this data, again, it doesn't really make any sense. So we're going to call it actually no correlation. There's no relationship involved whatsoever. So it says, as the number of shoes increases, remember we start off with the x-axis, the person's height in feet increases, decreases. No, it really doesn't make any sense, right? Some of you have a lot of shoes, might be shorter than me. A lot of shoes, might be taller than me. You might have like 3 pairs of shoes. But again, it really doesn't matter because there's no correlation there. Now this one here, it's kind of like a U. Number of days sick related to body temperature. let's see, what does that mean? This is nonlinear because it's not a line. Remember, we talked about nonlinear a little bit. We talked about the graphs. We did our vertical line test for a function. Then we also said, well, is it a line, not a line? As the number of days sick increases, the body temperature decreases. Because again, the body starts off really hot, then you cool down, but it might spike up again, then it increases. And then it decreases again, right? Yeah, nonlinear. So we've got 4 relationships or correlations. Positive linear, looks like it's going uphill. Negative linear, looks like it's going downhill. No correlation, and nonlinear correlation. All right, this information here is a quick graph. It's directly from your textbook if you wanted to look at it a little bit closer. The television size in inches. Now, this is a little bit outdated because I've seen TVs that are like 85 inches now. Crazy. And some of these TVs, oh, look, let's start off with this. Identify relationship between the data. Now, we can call it relationship, correlation, and so on. Does it kind of look like one of the 4? Yeah, we would say that it looks like it's going uphill, so that would be a positive linear correlation. We're going to write a sentence to describe the relationship, and we kind of talked about this already a little bit back in chapter 4. Remember, the x-axis is first, so as the television size in inches increases, what is happening to the price in dollars, which is the y-axis? Now that makes sense that it increases as well, right? The bigger the TV is, usually the more expensive it is. Outliers. Do you see this right here? Maybe that's something on sale, maybe like one of the off brands or whatever. But a 70-inch TV does not cost $2,250 anymore. A 70-inch TV may be like in the $500 range, which means all these other ones have also changed. So this is an outdated graph, but you get the idea. Positive linear correlation. As the TV size increases, the price increases. Here's our new scenario. The number of traffic cameras and the number of cars running red lights. Ooh. So this says we need to graph it, label the x and y axis, identify the relationship, and write a sentence. So again, it's just really quick L-shaped graph. This is what you did in elementary school. You concentrated on the positive values only in elementary school graphing. The x-axis, again, is the first set of information, the number of traffic cameras. And then over here, the number of cars running red lights. Now, when your parents drive, you might notice, again, when they come up to traffic lights, if they see a camera, they might behave a little bit better for traffic laws. It's kind of a natural tendency because, again, we do not want a ticket. Oh, sorry. So this would represent a bunch of the data, which means here it'd be like maybe 1 traffic camera. But down here would be a lot of traffic cameras. And essentially, and this is the way that cities kind of operate as well, is if there's more cameras, people are going to be driving slower, maybe a little bit safer, and running less red lights. Again, it's a negative linear correlation. Our sentence, again, we start off with the x-axis. As the number of traffic cameras increases, what happens to the cars running red lights? Oh yeah, they decrease. The number of cars running red lights decreases. That would be a negative linear correlation, because again, it kind of look like it's a linear, kind of linear, going downhill. All right, the scatter plot at the left shows the amount of fat in grams and the number of calories in 12 restaurant sandwiches. Really, it's just a way to remind you how to read your graphs, and we've done this before. You look at the x-axis, you look at the y-axis, you try and find the number. Again, just a quick refresher. How many calories are in the sandwich that contains 17 grams of fat? Well, 17 grams of fat, that's on the x-axis. So I look at where 17 would be, in between 15 and 20, and I would go up to the dot. And then it wants to know how many calories, so I just look to the left. As the line is there, hey, it's 400 calories. Again, it's just a quick way to remember how to read graphs. And then this one, it wants me to look at the y-axis. So I'm looking at 600 calories. And I'm going to go over to the dot and then down to the x-axis, which represents 30 grams of fat. So our question is really wanting us to describe the sentence. What tends to happen to the number of calories as the number of grams of fat increases? So we could say, starting with the x-axis, as the number of fat in grams increases, what happens to the calories? And if you notice, it kind of looks like a positive linear. So we know that the number of calories increases. That's what makes it taste good, right? The fat in there. That usually makes a lot of calories, though. All right, example 3. Example 1, example 3. It doesn't matter. Describe the relationship between the data. Identify any outliers, gaps, or clusters. So we already talked about outliers. We're going to talk about gaps and clusters as well. So if you notice, can I make a positive linear, a negative linear relationship, no correlation, or nonlinear? What's your first thought? Because again, we're trying to describe it. No relationship, right? Because again, I can't make a line going uphill, can't make a line going downhill, can't make a U-shaped graph or like a check. So it's just random data, no relationship at all. Because it says the person's age and the number of pets owned. Now, some people may say, like the people who get really old, they have a lot of pets. That's not necessarily true. Our outlier. Any outliers? If there's no relationship at all, can't really tell if there's an outlier. Some people sometimes say this might be an outlier, but again, it's just random data. You can't really tell. All right, gaps. Gaps means that there is missing information. But since it's not positive linear or negative linear, we can't really tell if it's missing any data at all. You would see like a significant gap. There's missing data. So no gaps. Cluster of data. A cluster is kind of like a cluster of grapes. You got a bunch of grapes. You got a bunch of data right next to each other. It'd be like 3, 4, maybe even 5 dots right next to each other. I don't really see that. I see 2 kind of close, but there's no actual cluster there. So no obvious cluster, no obvious gap. But again, that's what the definition really wants us to think about. The gap is missing data. Clusters, it's a lot of data right next to each other. All right. Oh, we can definitely describe this relationship as a negative linear relationship or negative linear correlation because it kind of looks like it's going downhill, kind of like a line. All right, starting with our outlier. Since there is a relationship, your outlier may be this one right here because again, if it would continue, that should be right around here, but it's not. It says heating cost in dollars. Month 7 heating cost, for us, that's more like air conditioning cost. So again, we look at the 7, and it matches up with the 600 on the Y. Cluster of data. It doesn't look like there's any bunches of data there, so nothing. Gap. No, there's no gap here, right? Some people may say, but it looks weird. Yeah, but again, it's month 2, month 3, so there's still data there. For a gap, it would be very significant. It'd be like here, and then it jumps to the next data, and there's missing information in between. All right, match the data set with the correct scatter plot. So I'm going to give instructions, and I'm going to actually ask you to pause the video. Hopefully you'll do that. And then you're going to try and think about matching it up. So answer A, B, and C, or really sentence A, B, C. You're going to try and match it up with graph 1, 2, 3. So if you think A matches up with graph 1, you would write A, comma, letter I. Match it up. All right, so I'm going to go ahead and ask you to pause it now. All right, welcome back. Hopefully you paused it and actually tried it. So let's see. I'm actually going to start on C because I know about technology is when computers get older, they lose value. Kind of similar to that car. So which graph as the x-axis increases, because remember that would be the age, the value, the y-axis decreases. So that would be graph 3, right? Because that would be a negative linear correlation. Looks like it's going downhill. Again, as a computer ages, the value decreases. Ooh, very important here. Quiz score and test score of each student in class. Is there no relationship, or is there a positive linear correlation? Meaning, as the quiz score increases, the test score increases. Definitely. The quiz score is kind of a good indication of how the students will test. So right here would be a low test score, goes up here. That would be low quiz score matches up with a low test score. A high quiz score going up would match up with a high test score. All right. By default, it's got to match up here, but month of birth and birth weight for infants at a daycare. So if some students, because in the past, some students thought it was the babies matched up with I, that means December babies way more than January babies. Yeah, that doesn't make any sense. So we matched it up accordingly. All right, quick reminder before we end, the relationships again. This is in your textbook. Positive linear relationship, as the x increases, the y increases. Negative linear relationship, as the x increases, the y decreases. And nonlinear relationship, the points lie in the shape of a curve. So again, it's kind of like a U or half a U. And then no relationship, just kind of random data going on. All right, so you're going to work on completing your notes and then work on completing the worksheet. If you have any questions, make sure you ask. That'd be fantastic. All right, be awesome.